So let's try some of these these Bohr models. See if we can identify the elements. This one right here, to identify elements, you look at the number of protons. This is number 11 on the periodic table, so we know that that's going to be sodium right away because the number of protons equals the atomic number. And if we look at the rest of the Bohr model, we know that sodium is going to be in the third period, so it should have 3 rings around it, which it has 1, 2, and 3 rings, so that's correct. And because it's in the alkali group, it should have 1 valence electron, because all these in the first one have 1 valence electron. The alkalines have 2. Then we skip over the boron. We skip over the transition metals. 3, 4, 5, 6, 7, and 8 valence electrons. So we see sodium has 1 valence electron, which we have 1 electron on that outermost ring. That's what the valence electrons means. And then all the inner ones are full, where we have 2 on the first ring, 8 on the second ring, and then that 1 valence electron on the third ring. If we were to count all these up, my number of electrons would equal my number of protons. We have 11 protons, so should we have 11 electrons? And we have 2 of those 11s on the first ring. We have 8 of those 11 on the second ring, so that's 10. And then there's our 11th, that lone 1 valence electron on the outermost ring. For this one right here, it doesn't tell us the number of protons, but again, we can just count the electrons. 1, 2, 3, 4. That tells us this is the Bohr model for beryllium. All right? And so of that 4, we have 2 on the first ring and 2 on the second ring. Because after 2, the first ring is full up, so I have to create a new ring and start adding to it. If I look where beryllium is on the period, it's in the second period. Hydrogen and helium's in the first, lithium, beryllium's in the second. And it's also 2 valence electrons, so it has 2 rings because it's in the second period, and it's got 2 valence electrons on that outermost ring. And then finally down here we have 16. It tells us the number of protons, so we know instantly that's going to be sulfur over here. If I look at sulfur, there's 16 protons, so there should be 16 electrons. So we have 2 of them on the first ring. We have 8 of them on the second ring, and so 2 plus 8, we're up to 10. So we got to put 6 more on that outermost ring. So 1, 2, 3, 4, 5, 6. We look good right there. And if we look where sulfur is, well, there's those 6 valence electrons on that outermost ring that we counted. And sulfur is also in the third period, so there should be 1, 2, 3 rings around it.